Hi guys, the intention of this video is hopefully to try to give you a link between chapter 12 and chapter 13, between kinematics and kinetics. I know I've done something like this before, but I just feel that it's good to repeat these things to give you more of a three-dimensional view. Okay, so in chapter 12, the basic idea here is to really show you how the coordinate systems overlap between the two chapters. Okay, so you can really say that this is a focus on the type of motion in kinematics and kinetics. When I say motion, I mean straight line, rectilinear, and curvilinear. Okay, and what coordinate systems we can use there. Okay, so recall in chapter 12, we saw two types. That's the kinematics chapter, which just studies the motion, right? Just the position, the velocity, and the acceleration. It doesn't study what causes the motion. That's kinetics, right? But in chapter 12, in the kinematics chapter, we studied two types of motion: rectilinear, that's straight line motion, and curvilinear motion. And recall rectilinear kinematics, straight line motion, we say there was a car or a box or something, and it was just going in one straight line. And in general, we defined it by just saying what's its position S. Well, essentially, straight line motion, you could also basically say that was the x-axis, right? So in a general sense, your rectilinear kinematics could have been described by the rectangular coordinate system. Rectangular coordinate system. Okay, that's your xy axes. Okay. So because it's a straight line, we could have just said that that's an x-axis. I think sometimes the textbook used it, but mostly it just spoke about the s. But that's really the x-axis. Then when we come to curvilinear motion, if you recall, we could have analyzed and solved these problems using two different types of coordinate systems. The one was a rectangular coordinate system. Okay, recall if you've got a curvilinear motion like that, then we could have defined our xy coordinate system and solved the problem using that. The other one is if you put the coordinate system on the particle. So if there was the particle was there, but our coordinate system was not placed on it, it was placed there at some fixed point. But with the normal and tangential coordinate system, we have the coordinate system placed on top of the particle. Okay, so the point is, for curvilinear, we could have used these two. Okay, rectangular and normal and tangential. For chapter 13, kinetics, again, we've got problems that involve straight line motion and curvilinear motion. Okay, kinematics, straight line, curvilinear. Kinetics, straight line, curvilinear. How do we solve these problems in kinetics? The rectilinear straight line problems, we use a rectangular coordinate system to solve these problems, and that is chapter 13.4. All right. Now, what I want you to take note of is that in the kinematics section, we used both rectangular and normal and tangential in the kinematic section. But the textbook over here in the curvilinear section in kinetics, it tends to only use the normal and tangential coordinate system. Okay? So I just want you to pay attention to this, that normal and tangential coordinate system is the preferred and only one that is really covered. Actually, I'm lying. There's also the cylindrical coordinate system, which we don't cover. Okay? But my point is that in chapter 13, in kinetics, under the curvilinear sections, there's only the normal and tangential and the cylindrical, which we don't cover. Okay? And the normal and tangential is covered in 13.5. Okay, so I hope all this waffling, you're getting a bit of a bigger picture and seeing how the coordinate systems and the types of motion are connected in chapters 12 and 13. Cheers.